about why we need inspections, why the codes department exists. So this, you've heard of the Hall of Fame. This is called the Wall of Shame here. So this would be no insulation on it. Used a lot of copper. Can't quite figure that one. You're not supposed to use combustible materials for your supply duct, so they've used some paneling, sheets of paneling here for supply duct on that one.
I've seen one made out of cardboard. I can do that.
Here, you know, the top discharge unit under the deck, so you just cut a hole and stick it through the deck.
No kidding.
These are all real photos.
It's hard to stop a train.
Yeah, these are all. Now they took the old unit with the pad out and then go in and use a. I doubt that's pressure treated.
No, but it's old.
Now don't say anything if you recognize any of these on some of you've inspected. There again, top discharge unit and up under a deck here. Well, you get a 50-foot line set. You don't have your tubing cutter. You just put her in. Go with it. Same thing. No insulation on it. No, I don't even see a disconnect. A lot of these I don't see disconnects on. Well, that solved that top discharge under the deck problem, didn't it? So you just hang her on the wall. Sideways. Had to get it up above finished grade. Now that's in. I'll bring that up while we're on it. That's in the 2012 where all the equipment's got to be 3 inches above finished grade. And then then the landscaper comes in and and then he brings it up, level with the unit, and then you got to go back out there and scruff it back down. That was going to be a tough one for you guys to inspect or enforce. I'd have to have a local amendment for that one. Like a condensing furnace vent on top of the air conditioner. Notice this one. Liquid, the dryer's in backwards. The dryer's in backwards on that. Arrow's going the wrong way. Filtering it backwards. I assume that one was a rooftop unit at one time. Curb adapters. Don't know what a curb adapter is. This is a 2-zone system. I mean that's terrible. Just the way it's tied into the old units. Looks like both of them are 2 old units and flex duct and just. Didn't it? A lot of flex duct. They didn't. I think the new unit that went in, they finally put a pitched roof curb in, but one of the other ones, it was just put on the slope of the roof without a pitched curb. This is before, and I think a tornado came through after. Let's see. There before. I don't know. They've got shelters built over 3 other units, and not on these. Small water leak while they were away. Got freezing. Yep. This little piece of paper right here is a Hewlett-Packard inkjet cartridge wrapper. I'm like, how would that get that coil is just, I mean, you'll be surprised when we tear out old equipment, we find something just that bad. Just that bad. This one, this filter doesn't cover the coil. It must be a downflow unit, I hope. And then that filter goes, so they compensate. They just stick that one up for the shortage here, I guess, on that. Probably a mobile home unit downflow on that. This furnace is upside down. That outlet on that venter should be at the top side, so it's installed upside down.
His tool bag is still there.
Yeah.
He's not finished.
Used I guess that's like a propane tank or something for an expansion tank or whatever. Float drain pan float switch, not hooked up. Going through a return chase. Look at the mold, and look, they got metal drain pans in the bottom of that return, catching the water, I guess, as it drips. So, pan of water sits in there in the airstream, and all that mold. That's in a return cavity. Listen, I think that flexible gas line is running right in front of the access panel to the furnace on that one. The gas vent on the furnace out of a piece of flexible duct. Could have used a better transition hookup on that vent. This one needed to be above the wall to get air moving through the vent cap, so I just put a little extender on it. So y'all thought y'all seen some bad. So fiberglass filters, you just throw the old ones in the attic and it adds to your R value, right? Huh? When you get through with it. This one is a piece of ductwork in a crawl space. Here's the Reflex. It's open-ended, got a filter with a brick sitting up there. You can see where it's been pulling the air back through that, pulling it right out of the crawl space.
That was the return for the conditioned crawl space.
Oh, okay. So that meets codes, right? I don't think that's a sealed crawl space on that one. There's the one you're talking about, cardboard. At first I thought this was flex duct, and they ran out and they used the cardboard box of flex duct. No, this is a letter size permanent budget master, so I don't just any kind of cardboard. You know, I thought it was the empty box at first, but it doesn't even.
But it's tape.
Duct tape.
Yeah.
They're going green. Yeah, they're recycled. Yeah, exactly right.
Those were some nice terminals on the end of those wires. Wire nut burn off there. Fuse blows, just bypass the fuse. Yeah. Went to too much trouble, didn't you, to move the wire? The panel cover has got to be on the. It might not fit, and it may not line up with the breakers, but he's got a panel cover on there. I'm not sure what this one. Where's OSHA? It gets better. Now get the guy is barefoot. You think he would have a cordless drill? You think he'd have a cordless drill? He's got a cord dangling over the water on an aluminum ladder, and he's barefoot on the ladder. Hey, he's got his eye goggles. He's got his eye goggles on. He's thinking safety, right?
That's probably a double insulated tool.
All right, that's. Okay, I think we're on section 3 here. Okay, some of the just knowing how to read a set of blueprints and knowing how to measure an existing house is half the battle. I mean, the first thing you got to do, I normally sit down with a legal pad and take all my measurements off first. I kind of got a formula that I go by. I take my outside walls, and then I do my glass and my doors, and I deduct that from my glass. And I found these little project calculator, because you can do feet inches. I'm sitting here trying to calculate, I know 6 inches is 0.5, but then when I get 7 inches, I'm thinking about it. Well, these are pretty neat to calculate feet inches when you're doing it. And then on the larger plans, I like this little, it's got the little wheel on it. So you can start it, and then you can just run around the perimeter of the house, and it'll give you the linear feet on it, so it works out. You can set the scale on it, whatever plans you're working on. So that's a nice little device to. So I use both those quite often. But knowing how to measure doors, you'll notice the door area is 21 square feet, window area is 12 square feet. So you take your gross wall area, less your windows and doors, so it'll give you 207 net wall area. Have a lot of people struggle with the walls and figuring the net area on it. I can't tell you how many they have the square footage of the house the same square footage as the walls. I'm like, where did you get that? So knowing how to measure dimensions, areas, perimeters, and volumes, you've got to know how to do that to run an accurate load calculation. When I sit down at the computer and run the load, it probably doesn't take me 2 minutes or less. It's just punching the numbers in, after that. Knowing how to figure, let's just say if this was a cathedral ceiling inside, well, this area of that wall is exposed on it. So you got to know how to figure the area of that, which is the square, half of the square on it. Same thing when you've got part below grade, part above grade, how to figure which part is which on that. Kind of show you the wall section to look for. You've got siding, insulation, chipboard, or brick, and air films. I won't spend a whole lot on this. It gets a little technical. Let's talk about that, the temperature differences between inside and out, and wind pressure. We're in a medium range, so our temperature swings from daytime to nighttime are somewhere between 15 to 25 degrees. That's what that means on it. Let's see. Talking about the duct loads. So this would be the one I was telling you about, losing temperature of the air before it gets to the end of the ductwork if it's poorly insulated where it's located. One I had was just the opposite. It was in a hot attic that was poorly insulated, so I was losing. I should be looking at about a 20-degree drop in the airflow. I was getting like 13 by the time it got to the register on it, so I was losing a lot of capacity that way. Vapor barriers on the ductwork. You saw the situation in the crawl spaces. I mean, it'll sweat a big time if it's out there. Maintaining that vapor barrier is big too. I think just, do you require tape over the staple joints on the vapor barrier here, maintaining it? Remember I talked about the blower heat? The blower sits in the airstream, so it's about 1,700 BTUs that needs to be added in. Moisture migration. Where do you put the vapor barrier? It depends on where you live. Let's go to 4. This is the survey. It's hard to read this sheet, but there's all the things that you probably, if you're sitting down with a homeowner or a builder, you need to ask. You know, what direction does the house face? You know, is it 1-story, 2-story, split level? Just all the insulation values for all the different components. So you've got to know that when you get ready to do your load calculation to pick the right, components to use. It's a little bit expanded view where you can read it there. Location and outdoor design conditions using table 1. We talked about, are there any zoning requirements that may be needed? Indoor design. Plans and sketches. I can't tell you how many times that I get a set of plans, we run the load calculation, we design the ductwork, we go out to put it in, and it's changed. They added something, changed something. So need to know before you show up to do the job. All of a sudden your material list is not right, your equipment may not be right. When the builder makes changes on it and doesn't relay that back to you. But knowing how to read a set of blueprints and take those measurements too. A lot of times we only get a bird's eye view of the floor plan. I never get the elevations. So if I don't have a window schedule, I can't scale the windows off on it. So need a good detail, need window schedules, need elevations, need a lot of information than just something drawn of the floor plan makes it hard sometimes. There you go, we talked about the measurements, areas, volumes, just knowing how to measure those correctly. Pretty much the box, what makes up the box? Heat will come in or out, so it's the walls, ceilings, floors, windows, and doors, skylights, whatever makes up the box. Some ideas of different areas that, knee walls sometimes are missed. Roof ceiling combination, ceiling under a vented attic. So you got three different types of components there. That could be a regular outside wall. So that's 4 different exposures. Same thing, you got part of the garage exposed in there. There again, we saw how to measure windows and doors. We saw that one. Yeah, there's a good one. You got, see, that's exposed. Those shaded areas shows you where you've got exposure on it. It's hard to see that from just like I said, that bird's eye view of a plan on it. This we saw on the other slide. Different kinds of windows. Is it fixed glass, operable, double hung, casement, jalousie awning? There's the ratings we were talking about on the sticker right there. Doors, what we do is we measure the glass part of the door. So if that was 20 square feet in that door and 15 of it was glass, we count that as glass and the balance of it as door on it. Skylights. A lot of detail to skylights, the type of curb, and if it uses a shaft or not, and if the shaft is insulated when it comes down, the light shaft. Basement floors. So it's showing you there's no temperature across that part of the slab. Slab on grade, we use the perimeter of it. Basement floor slab, we use the square footage on the measurements. Talk about wind pressure on a house, which sealing it up. That's what the blower door test is simulating that. When you put the blower door up, you're trying to see all the places that air could get in. Remember I told you there's 5 different, tight, semi-tight, average, semi-loose, or loose. So some of the older construction is going to fall, down here. Probably the tight would be your energy saver houses. I don't know that I would use the tight for the code. I'd probably use the semi-tight for code on that. There again, survey form. Meeting with the homeowner or the builder on everything there. Okay, we talk about different types of loads. The envelope load is the box. Everything's coming in through the box. The design loads, we typically run a block load to size the equipment. We run a room by room load if we've got to get airflow requirements on it. So if it's an existing home and the ductwork's already there, I'm just running a block load to verify that the unit that was installed is okay. If they've added insulation, they've got new windows, and they've done some weatherization measures, and they've got that 3.5 ton or 3 ton system, I might be able to go back with a 2. The ductwork should be okay because it's a little bit larger on that. And I'll ask them if there's any rooms that they may have any problem. If it's got a 6, I may change it out to a 7. But it's new construction where you've got to comply with the codes is where you'd have to do a full room by room load calculation to get the airflow requirements to be able to size the duct on that. But we run an average load procedure, not the peak. This tells you, remember I told you different types of duct systems and where they're located. It's in the attic, the crawl space. So try to select one of the tables that closely matches whatever you're putting in on that. There's that blower heat again. Humidification. There again, that's another picture. Everywhere heat could get in or out of the house. A little bigger view of it. So there's the equipment sizing load, typically your block load. And then that's the data you need for equipment selection. So only different, we need to know the humidity design on the inside, which is normally 50%. We try to maintain 50% humidity. That should be, if you're looking at manufacturer's data, we should be looking at what does that equipment do at our design conditions at 75 degrees outside, 63 degree wet bulb, and 75 degree dry bulb. And I know TVA used most of your equipment manufacturers now has the TVA design condition in it. It used to be 62, and TVA wanted that 63, so most of them have the 63, so you can select that now. Well, the ARI specs, if you went onto their website and you had to print one of their certificates, it's at 80 degrees. Well, that's not. We need to know what that equipment's doing at 75, not 80. There, so.
Around here, we design 75, and that's what most people keep the thermostat somewhere.
Right, right, right.
The other is 75.
That's why we say use the manufacturer's sheet, not ARI data, when you're only using the manual S. There's one thing on the big book, is they call it the adequate disposure, called AED. It's looking at, is there a lot of glass in one area that's going to peak out in the day, and that could cause your load to bump up a little bit when that happens. When you run through it, you'll get, that's got exposure diversity, that does not. And the computer program will add a little bit more to it if it sees you had. And you pretty much need software to do that. So real brief on AED, if you ever hear that terminology come up. 6. What to do next? Check your work, trust your work, review the system concept and the suitability of the calculation tool, use manual S and the manufacturer's data to select the equipment. Manual T selects your registers and grills. Manual D decides the ducts. Make sure you comply with all the codes and standards. And then system commission, go back and start the system up. Make sure you check it after it's installed. Go back and do a startup, record temperatures, record pressures, record airflows to make sure it's doing what it's supposed to be doing. The very first thing, if you don't have adequate airflow, you can't test anything. So that's the first thing we have to do, is measure our airflow. We get our airflow, then we can check our temperature differences, and then our superheats or subcooling on it. Check your design conditions, make sure you're using those are correct. Just double checking your work. I think we've pretty much seen all this. I know some of you have done manual J. Have any of you done manual S, equipment selection? Because manual J runs a load on the house. That's all it does. It doesn't tell you what piece of equipment to use. You assume, oh, that's a 3-ton load, but you may find a piece of equipment that only does 32,000 BTUs of capacity, and it says it has a 3-ton load. Well, that's going to be a 3.5-ton unit to go on that house. And I've seen a train unit be one size and a carrier unit be another size for the same house, depending on how their capacities are. So the manual J is not for equipment selection. It's only giving us the load that we go put in manual S to determine the equipment selection on it. That's designed in manual D, manual T. And make sure you follow any codes or standards that might apply. The ACCA's come out with a quality standard. So if you're going to be doing homes that are Energy Star 3.0, you've got to be certified by ACCA to do that. It's just a matter of going online and filling out a lot of forms and, yeah, I promise to do this, I promise to do that, and you could be subject to an audit where they'll come out to make sure that you're doing everything you said you'd be doing. But there's very, very few contractors in Middle Tennessee area that have signed up for it.
What's the cost for it?
You know, we did it. We're a member of ACCA, so ours was cheaper. You do not have to be a member of ACCA to do it. You do it, but it's cheaper if you're a member. And then we did it kind of before they had a price increase on it. I mean, I think ours was $300, you know, to do it. I don't. We hadn't been in place a year yet, so I'm not sure if it's going to be an annual renewal or not. But there's a, you know, here's the Energy Star 3.0 checklist. I mean, you got to do everything. You got to fill this out, everything that's on this sheet to comply with. And you're going to find more and more builders are wanting their houses to be Energy Star. I think that's where you'll get the, the gentleman before was talking about, you get credit for that, being Energy Star. But if you're not on there, I would advise, let's see, I may have, here's the website right here. So you go to ACCA, Quality Assured Contractors here. See, here's the cost and fees, application. Everything is in here. I think you can even contractors directory. So anybody can go to this directory. Just go to ACCA's website. You can figure, it'll tell you everything you do pretty much online. Internet connection's slow. Maybe it'll come up. I'll minimize it right now. Okay. For all of those manuals, J, D, ASN, whatever, I've created Microsoft Excel spreadsheets that come with the books. It's not in the back of this one because this is the first version, and we've updated it several times. So the spreadsheet is on the website where you can download it. So it makes it real easy. If you have the book, it's a good companion to have together. And I'll run through a sample load for you here. Let's see, where are we? This one I've already got one filled out, for time. But basically, you'll go anywhere there's a white. Does the color show up back there? Yeah. Okay. Anywhere there's a white box, that means that's where you enter information. Any of the green is just where I put text. These are formulas here. But you select your city. It's a drop-down box, and we select Tennessee. And then here are all the cities that are located in our area. So you would select the closest one to you would be, I guess, Chattanooga, probably here for design conditions. On that, I can change it. It'll give you the 20s your outdoor, 92 is your summer, 20 is your winter. So it'll pull all that information out of the manual and put it there for you. So all you got to know is what's the closest design city that I'm looking for. Here's that 70 and 75. You can change that. That's where they recommend you don't on it. So the way this works and the way ACCA wanted it is there's lines and lines and lines and lines of information. That's what gets people confused when you set them in front of the computer. They really don't expect. You take the book and you go to the book and you'll come, let's say, to the doors tab, and you put the doors in there that are most commonly used in your area. 3 or 4 doors. That way you don't have to go through a whole big list. When you go to glass, we put the most common, and I've just got a few in here. I've got double pane, operable with a wood frame, same thing, metal frame, and I've got 2 with blinds at 45 and 2 with no internal shade, just to show you. So you build your template like you want it for your geographical area. You can even make one, if you've got a builder that builds with certain components, you can make one up and save it under that builder's name. That way when you pull it up, all you got to do is go put the square footages in. Take you just a few minutes to do that. So you go through, take your book, you buy the book, the spreadsheet's free. You buy the book and the spreadsheet's free. Then you go to the walls, see, I've got several different, I got R11 with 2 boards, I got R13 with R3 board, R15 with R4. I just put those in out of the book. That way, and the ceilings and floors. Remember, the yellow cells are where you put information. So you would populate those 5 areas. And then when you come back into your, the only schedule you got to go to is the glass. Just like filling out income tax forms, sometimes you got to fill out a schedule. So the only way you got to fill out is the glass schedule. Here, whatever you put over there, you got a drop-down box for it here. So you can select that. Put your direction. That's a 5. Put your overhang distance. And top of that, what that's doing, that's figuring that shade line factor for us on it, right there. And any projections, you know, if it's a garden window, bay window, I'm going to put none. Or it had bug screen, you do bug screen there. So that's the only schedule you got to fill out. And then when you come back to your J1 form, that information will already be there, and then you just put your square footage here. So if you wanted to do a whole house block load, you just put one room right here. You just put whole house, and you just run down one like it's one big room. But if I want to do a room by room, get that out of there, then I can just slide to the right, and I can put all my rooms here. So I've done a room by room on this one. So I have utility, kitchen, dining, 3 bedrooms, 2 baths, and living room. And then all that information will sum up and come back over here. Or I can do one big room and call it the whole house. So you can see I didn't have any glass on the north. I had 136 on the east and the west, and I had 24 on the south. And then that'll give me my corresponding heat loss and heat gain for that. Then you can come here. All you have to do is select, once you've put them in there, and you can save this template with them already up and no square footage, and it makes it real easy. So if I want to change that from a wood panel to a solid core, I just change it. You put your square footage here. See, I've got that one loaded in, but I didn't have any square footage. I can put 20 square foot. Normally you got a nice 6-panel wood door on the front of the house, pretty door, and then you got a ugly door going into the garage. So metal polystyrene core. So you can do your doors here. And this is what causes people problems using software that they're not familiar with. If you sit down and you go through the book and you put the information in here, you're familiar with it. These are the things that we use. Houses built in Maine are going to be built different than houses in Seattle versus Florida. So we can take what are the commonly used building materials in our area and build a little small database. So when you get there, it's just a few selections you got to look at. It's not hundreds and hundreds and hundreds that you got to wade through. And that's the confusing part. Which one do I use on that? So you figure all that out. You can make a template for houses that were built 1985 and before, older houses. You can have that template already built where all you got to do is pull it up, put it. You can have some type of new construction for a particular builder, high energy house. You can build as many different templates as you want and save them by their name. So here's our above grade walls. Like I said, just select whatever you put in there. We'll do a R13 with an R3 board. Ceilings. So I put roof ceiling and vented attic. I've got 3 different choices in there. That's over a crawl space. And then just put your area out here and it'll calculate for you. Here's your envelope leakage we talked about. That's that tight, semi-tight, average, semi-loose, or loose. So I'm gonna run this one at average. It needs the square footage of the house and the volume of the house to do some of the other, to know which tables to use within the program. So you put the heated air, it says 1,890 square foot house, and that's the volume times the ceiling height. The occupants are always 2 people in the master bedroom and then 1 person in each other bedroom. So this is a 3-bedroom house, so I got 4 occupants here. And what will happen is if I put, see, I get an error message because I put 5 people in a 3-bedroom house. It won't let you do it. It's kind of a protection there. So if I take that person out of the living room, so the people were put in, you know, over in these rooms, 2 people in the master bedroom, 1 in bed 2, 1 in bed 3. Same thing on appliances. You've got 3 different appliance loads. No appliances, no appliance load, 1200 or 2400. 2400 is the default on the 8th edition. But if I go over here, see, I've got 600 in the living room. Maybe that's a big screen TV and some other thing. But if I made that 900, they have to all add up to that 1200, or it won't work on it. So it has to be whatever you put in the rooms has to equal what you've selected here, 2400. But the rooms have to equal that. That's just something they made me build into the spreadsheet so people couldn't cheat and put a lot of people, put a lot of appliances to make the load go up. You can't do it. Here's that duct table. This is a trunk and branch, supply and return in a closed crawl space or unconditioned basement. My R value on the R8. If I was running a load on an older home that might only have R4 insulation, I could change it there. And then just like the house leakage, you got the same thing here. This would be average, semi-tight, tight, semi-leaky, or leaky. We'll just do average tightness on the ductwork. And then here's that blower door. It's got it in there now. You just choose to take it. It'll either be no blower heat, or it has blower heat. So that came out to a 22,504 sensible load and a 3,027 on the sensible. So when I look at the manufacturer's data, I'm trying to size it to satisfy the sensible on the equipment, satisfies the sensible on the load, the latent. You don't add the two together. People make that mistake. They add the two together, divide it by 12,000, and figure their tonnage. That's not correct. So it's real easy to do. So I've got what we'll do. We'll make a best case scenario. We've got. It'd be hard to do it on a full load though. I was going to move stuff around. If I didn't change anything, I can just show you. It's a 22,000 BTU load. If I carry this ductwork to the attic, it went to 28. And then if I said that ductwork was leaky, it's gone to 40,000. I had already changed the R value, but if it was 8 before, then if you said that leaky ductwork in the attic only had 44, it goes from 35 to 40,000. So just 3 entries there, I've almost doubled the load on that house. That doesn't count if all the glass was on the west. I mean, and I can flip it. I can put most of the glass on the north. I can have the best condition for the ductwork, and I can get that thing down to like a 1.5 ton. I can take this one house, and so that's why there's no one size fits all on it. But the spreadsheet's real easy to use. Like I said, you can see how many. If you save your template with some of these in here, you just come into this wide area and put it in, and 60 seconds you can have a load run. Real easy. It'll give you a summary form over here if you did a room by room. This will give you your airflow that's needed for heating or cooling. See, that bedroom 2 needs quite a bit more air cooling than it does heating. Both of them do.
This may be a stupid question, but that assumes all doors, interior doors are open for this all to work? Because you're calculating the load, but if that room is sealed up, the door's shut.
Yeah. I mean, closing a room off on a whole house system really, it's not going to do a whole lot. I mean, I'm sure in our area we use central returns, one big return grill, so typically they need to undercut the doors in case they are shut to get some flow back, to the unit. But then you go south of here to Atlanta, they put a return in every room and filter it at the unit. That's why I like filtering it before the ductwork. Keeps it a little bit cleaner. But yeah, this is assuming everything. They're not going to save much by trying to close a room off. They're going to let that room get at a higher or lower temperature, and it's uninsulated and leaky into the rest of the house. So there's just really no advantage to that.
So I guess I'm guessing like on an older house, would you be better off
if you're
I
going,
had 3 different air conditioners in my house. I had a split unit, single unit, split unit. It was all messed up.
yeah.
So, you know, I could do this. 'Cause,
I mean, you can't put air in a room unless you take it out. You can't pressurize it, so there's got to be some relief of getting the air back out to the return before you can put it in there. So if the doors are not undercut on some high shag carpet or something, and the door shut, temperature is going to swing in there because it just so in that situation the air returns are, bigger homes we'll put 2 returns. If it's a bonus room, we'll put a return in that bonus room to try to get it back as best we can.
Also, the Schedule J, like you've got the big room with lots of windows, you
Yeah.
put more vents in it.
Right.
To take care of that.
Right. See that living room's got 473 CFM in it. It's a bigger room, a lot of glass on it. Then this will tell you where it is percentage-wise. So you can see, look here, our duct loss and gain, since I made those changes, look, it's 48% of our load. So a good, tight, sealed, properly insulated duct system makes a huge difference, especially if it's in an attic. Move to the crawl space, it's not as bad on it. And glass, which can't do a whole lot more to glass, it is what it is. Just getting some good, maybe low E type glass in it. Some of the others you can see you can kind of tell where you need to work on. It's here. So that infiltration's 2.29. I can go back over here and I had it at average. Well, if it was loose, then it went to 4.58% of the load on it. So this is a good little chart. Lets you look at and say, well, if I'm going to spend some money, I probably need to be spending it right here on that. And getting duct work in the conditioned space is, that's even best. You can keep it out of the attic, and I don't know how. There was one shot where, you can drop the ceiling height in a hallway down a little bit and try to get it there some kind of way. But getting it makes a huge difference on it. And the equipment, getting the equipment out of the attic makes a big difference. I know a lot of people will put a mechanical closet on the second floor to put an upflow air handler or upflow furnace in, and then shoot the duct work up. So just keeping the unit, that's half the battle because it's leaky. It's leaky, it's poorly insulated, so getting it out of the hot attic helps as well. But manual J's, no need to be scared of it. They're relatively, reading the blueprints and getting your measurements is half the battle. Going here and picking the right building components is the second half of it, and then, it doesn't, just like it said, go back through after you do it, take a look. Look in here will let you know, you say, well, why is that so high? Well, then you can go back and look and see, well, I'll come back over here, and I'm going to say, well, that's actually got R8 on it, and, I've got that thing sealed up pretty good, and it's actually in the crawl space. So we went from 48% to 4%. Changed your percentages everywhere else on here. So if I was looking at something, if I was an inspector, would be the duct systems. Make sure they're using the airtight takeoffs and sealing up all the joints and yes, duct blaster. Yep. Yeah. Yeah. If we ever adopt the 2012, you'll have to do duct blaster tests. Yeah. But one of the biggest problems we see is let's see if it's not in that. Where did I put it? Screwed up, man. well, I can't. Let me show you one thing about an encapsulated attic. The spray foam insulator guys were going out claiming all this big savings, and the biggest savings, we just saw that, is when the ductwork is in the attic. If the ductwork is in that crawl space, they can't make those claims. They can't reduce your tonnage by 1 ton or whatever like they claim to do. And this is a good way to show it. If you had, this is the encapsulated attic. We're giving good credit here. We're saying the attic temperature in the summer is only 79 degrees. And we've measured them. They're 79, 80, 81. They're pretty close, to that. 62 in the winter. But we're putting no insulation right here. Just a piece of drywall. Well, the heat loss and heat gain, although it's only a 4-degree temperature difference in the summer across drywall, is 1,632 BTUs. Versus the spray foam, it's 130 degrees, or that's the spray foam. Conventional is 130 degree attic, but I put R38. My heat gain is only 1950. So I'm at 1950, he does spray foam, and he's at 1632. So where's the savings? I don't know why there's not a little bit of insulation put on top of that drywall, to me. Because it's just 4-degree difference in the attic, but it's still that much heat loss or gain through it. So, so this is just an example of if you ever run up on that. Now, if the ductwork was in the attic, in the hot attic, then we just saw how you could save doing that. There's savings on it. But it's just a single-level ranch house, and the ductwork is in a crawl space. It's not there. It's just not there on that. We talked at the break. This screwed up manual J. You're talking about. This is a HERS rater who was checking a contractor's loads. He said, I was checking some rim rate files for our HERS rater yesterday, mostly submitted for the Energy Star homes. I've come to expect manual J heating cooling load calculations submitted along with the files to be less than perfect. Mostly I accept them because they're close enough. Yesterday, though, I received a manual J to go along with the file for an Energy Star home that was beyond the pale. It was horrific. It did come close to meeting the Energy Star version 2 requirements for manual J, which were tight or semi-tight infiltration and the correct design temperatures. But whoever put this one together was singularly devious in his efforts to justify the oversized air conditioning system he wanted to install. He did the usual things to fabricate extra cooling load, but when that wasn't enough, he resorted to one trick that's not used nearly as often as it might be. One of the first things I do when checking to see if a cooling system might be oversized is to look at the ratio of conditioned floor area in square feet to the cooling capacity in ton. Energy Star and other high-performance homes usually come in around 1,000 square feet per ton. A lot of HVAC contractors, though, don't normally do manual J sizing calculations, but instead they rely on rules of thumb, mostly 500 to 600 square feet per ton. This house came in at 368 square feet per ton. That's ridiculous, especially for a house in Charlotte, North Carolina. When I went through the reports, here are the problems I found that are typical of bad manual J's. They put 6 people in the calculation when this house should have had 4. That's why we have that error correcting message in there. It should have been the number of bedrooms plus 1. The HERS rater calculated that the house had 184 square feet of window area. The manual J had 384 square feet of window area. The HERS rater used a window U value of 0.32. The manual J had 0.53. Lower is better. So he intentionally went in there to make changes to bump that load up. These 3 items alone inflated the cooling load significantly. Not enough for this contractor, though. Evidently, he really wanted to install a 2.5-ton air conditioner for the upstairs zone. Yet after all those shenanigans, the manual J result was only 1.5 tons. So what did he do to get the extra ton to show up in the manual J? He could have gone in and changed the wall insulation or the duct leakage or any number of other parameters, but there was an easier way. Manual J calculates the sensible and latent loads separately and adds them together for the total, but the sensible load is how much cooling you need to bring the temperature down, and the latent is how much you have to bring the humidity down. If you take the sensible load and divide it by the total load, it's called the sensible heat ratio. So the Manual J report, often submitted, shows the total load plus sensible latent. It also shows what they call the required total capacity of the equipment at a particular SHR. Whoever does the Manual J can override the default SHR of 0.75, and that changes the required capacity. Most air conditioning equipment comes with an SHR in the range of 0.7 to 0.75, and that's changing. It's about 0.8, 0.81 for new equipment, these days. So, and that's what you need to do is you need to go look at the piece of equipment you're going to put in, divide the sensible by the total, and that'll give you that SHR to plug in the program, and that'll tell you what piece of equipment you need, what size it needs on it. So the crafty calculator who completed this Manual J figured out by adjusting the sensible heat ratio that he could get the required capacity to equal what he wanted to install. In this case, he needed a 0.53 sensible heat ratio to get to his 2.5 tons. Can you even get an air conditioner with a 0.53? So I've already had 2 sessions with Nashville code building inspector, mechanical inspectors. All they want me to do is teach them how to spot this kind of stuff. They don't care about running the load. They want me to teach them how to spot that stuff. So that's kind of what they're looking at. There's some certain things that they'll be looking for, especially in the field. They're not going to look at every single pipe connection to the trunk line, but they're going to pull the insulation back and look at 2 or 3 to make sure that they have been sealed. They're going to look and see if the run-out's been sealed to the boot's been sealed at the floor. Spot check some of them like that. But
they don't require duct plaster up there?
Nope. They currently do not require Manual J as part of the permitting process. But if there's ever an incident and they walk into your place of business and say, I've got a call from homeowner so-and-so, they've got an issue with comfort, I need to see your Manual J you ran on that house. And if you start trying to fabricate one, they're going to nail you. They say you should run it, you should have it in your job file, you should put it in. I guess the policing of it, So I don't know how Mount Juliet is requiring Manual J, Manual D, and Manual S for permitting processes. So every codes jurisdiction that you go into, it's good that you got the county and the city trying to get on the same page. Where we are, Brentwood does it one way, Franklin does it one way, Williamson County does it another way. It's all over the board. Some are on the 2006, some are on the 2009, some are adopted in 2012. So we have it's a hodgepodge of knowing what you got to do if you go into each one of these areas. It is tough. But like the gentleman said this morning, it is part of the code to run a Manual J and to select your equipment. Now, the wording in the current code just says by Manual J, but the 2012 code says, let me find it. QA. I think I lost some of my files. Here it is. Okay, I think this is common between all of them, 6, 9, and 12. It says heating and cooling shall be sized in accordance with section 1403.3. And then 2009 and 2012 say something different than 2006. It says heating and cooling equipment and appliances shall be sized in accordance with Manual S based on the building loads calculated in accordance with ACA Manual J or other approved. And that means there's some things out there that aren't approved. So it's probably best to stick with ACA because we know it is approved. But this is the wording on the 2009 and the 2012 IRC. And on the ducts, it says ducts shall be installed according to 3.2, and that's getting into the ceiling. And you notice they've got these words in here, mandatory. Some are prescriptive and some are mandatory.
We were talking about that a little earlier too. What are mandatory materials to be used?
No, it just means that enforcement of that code is mandatory in the 2012 on that.
But they also, once they go to certain ceiling.
Yeah. There's certain the 181 mastic and the tape. It's all of it has labels on it now, and I know our inspectors, they look for that label. If they can't see that label on that tape or mastic or whatever.
Yeah, one of our guys was having a problem with UL 181 tape. He's not sticking, apparently something's wrong. We said go back. Well, no recommend he goes back to his supplier and say
Yeah.
that's the same tape.
Yeah.
Because most of the 181 tape, you stick it on and it's on you keep pressure.
We've seen some that's not as good as others. We've been using this Flex Fit. It's kind of more of a flexible. It works great on Flex Duct, and it sticks to everything. You can't get it off you. Yeah. But there's specific requirements for that. There it is. It used to say the 181 on that.
In the 2006, joints and seams, M1601.3.1, joints of duct systems shall be made substantially airtight by means of tapes, mastic, gasket, and other approved closure systems. It goes on to the 181 UL approved stuff, the UL 181B.
Yeah, the 181.
Joints and so forth.
Yeah, that's what our guys are. They're looking for that labeling on the tape that says 181. I think it's red in color, and others are black in color. I think so. They know if you've used the right tape, it's going to have the red
When
letter.
it says tapes there, that's what it's referring to. It's not referring to the guinea duck tape. It's referring to a approved
181.
Yeah. And like I said, the wordings have changed some from 6 to 12. I don't know if they just left that out. And here it is. It's a continuation of the first. So 181B FX for pressure sensitive, 181B for mastics, 181B-C. So it's a big. It's actually two parts there, maybe three. Yeah, it's even more. So that one cut at 1604.4.1. It's a lot going on there.
I got a question for code assistants out here. Are we now, because I've seen, the suppliers and they'll sell a lot of tape that's not UL 181. I see a lot of that tape. I've got some of it on my truck and all. When it comes to installations now, are we saying this is what we're going to be going by is using UL 181
That's
on
That's
all our
what the
ducts?
code requires us to expect.
So that's what's going to be being looked for on new and replacement duct systems is UL 181.
Do you know why they're carrying both? Because they got guys that live out in the rural areas that nobody's enforcing it.
Polk County tape.
So they're going to carry both. The other thing they did in Nashville is this is the gospel pretty much for installing flex duct. I'm gonna tell you what, that has been the biggest thorn is how flex duct is installed. So we adopted this little book here. Yep. I mean this is your Bible for putting in flex duct system. So I'll run through the Manual S program with you. This is based on the Manual J-Load that we just ran. We put the customer's name, the design city here, our design conditions here. Then we'll put our sensible and our latent capacities in, and it's going to automatically calculate that sensible heat ratio on the house. Total load and then the heat loss. And then here we put our manufacturer, the coil, or the fan coil model number, the condenser model number, and if it was a furnace. This happens to be a split heat pump, 13 SEER 8.05. And then we go to the manufacturer's data, and that looks like this. And this is the area we're looking at. We're looking at 75 degrees inside, 1,050 CFM on a 95-degree day, and 63-degree wet bulb. So there's our areas right there that we're looking at. That's our total capacity. See, that one has a 0.81 sensible heat ratio. So it's newer equipment that's come up. There's more sensible capacity and less latent capacity on it. So you're able to get by with a little bit less tonnage in some borderline situations on it. So this is the information we're looking for to put in our manual S. So at 1,050 CFM and 63-degree wet bulb, our total capacity was 26,300. Then the computer program will do everything. They have what they call excess latent capacity. So if you're not using, if there's not enough latent load on the house, remember it was like 0.87, it takes some of that latent capacity and then converts it to, it works on the moisture first, and then it'll start working on the sensible. So what the manual S does is it adds 985 to the sensible and takes 95 away over here. So it puts it over here to give you a little bit more capacity on here on this side. So that tells us we're running a 0.81 sensible heat ratio there. So these are the numbers we're looking for too. We're at 105% on our sensible. Allows you up to 115% oversizing. So if you turn this in and you're 122%, you're not according to codes, unless it's a heat pump and you live in a cold weather climate. Then you can oversize the heat pump to get a lower balance point on it.
How much can you oversize?
25 on a heat pump, right. So this will let you look at that. Our total capacity is 108. Our sensible is 105. Look at our latent. Well, we got plenty latent capacity for this particular house because our load on the house was so low. Then if you'll put the heat pump capacity at 17 and 17, it'll calculate your balance point for you and then calculate how much supplemental heat is required. We had a low heating load on this particular house. And then if you were doing a furnace, you'd fill in that information here. So this is what you need. This is the most critical area because this is where it's going to do all its calculations. If you ever need to go back and check on you, I need to say, well, what model number, coil, and what condenser did he use to figure that? And that way I can go and verify his numbers to see what he turned in, see if all this is correct down here on it. And then the manual J, verify those numbers up here. Well, like I said, we're looking for this to be, we don't want this to be 87% of the load. Don't want it to be 130% of the load. Anywhere between 100 and 115% is where we're trying to hit. And you can mix match coils. Sometimes you use a 3-ton coil on a 2.5-ton condensing unit and maybe, make your numbers work out there. Changing the airflow sometimes. More airflow will give you a little bit more sensible capacity. Less airflow will give you a little bit more latent capacity on it. But that manual S is probably the easiest one. I know TVA, it's kind of the same. If you've ever done any TVA jobs, it's basically the same thing you were doing on a TVA job, except there's a form for it. Then on the manual D, what we did, the first thing you have to do is figure out your equivalent length of the duct system. So I had 58 linear feet of trunk line to this run out, and that run out was 20 linear feet. You got 4 choices. You're looking at your duct design. You're trying to determine which is the longest in the system. Some of them it's a no-brainer. You can tell, and that's the one you would figure. Here, I can't tell if S5 or S6 is the longest run, so I'm going to run them side by side. This one's got 55 in length and 15 feet on the run out. So then what you do is you have to figure the effective length of your fittings. In other words, I've got a Group 1 Type C fitting, so you can go to Group 1. A 1C, there's 35 feet. So a square box plenum with takeoff like that is equivalent to 35 feet. Same thing if it was a round pipe coming out, it's the same 35 feet. But look here, if you had a squared around takeoff, it goes down to 10 feet. So there's ways to reduce that equivalent footage down. So I had a 2A fitting. 2A fitting. What's that going to be? Up here. That was probably my takeoff at the trunk line. So you take your total length of everything, and every time you've got a fitting, it has an equivalent factor for it. So that was where my round takeoff was at my trunk line. So I won't go through all of them, but I had a G4. So that was my boot. So you go to 4G. Where's 4G? 4G right here. Look at that. 80 feet. 90 boot. It's equivalent to 80 feet.
You mean you're not supposed to just use whichever one you have left on the truck?
Yeah, it just,
Yeah,
there's,
have a 4G.
a straight boot with an elbow on it is much less than that 90 boot, like that. So what it does is now with my measured length and all my fittings, that has a total equivalent length of 318. This one came in at 280. So the design will look at all four of those and determine which one has the longest total equivalent length. So 318 is the one we're going to use here. Then my return, you do the same way. I've got one return. It was 20 feet. I didn't have to compare, but I had to put my fittings in. So I have 145 linear feet or total equivalent feet on my return. The second step is you go to your friction rate chart here. So you'll go to your chart. You say I've got at 0.5 inches of water column on medium speed, I can move 1,050 CFM. Then there's a 0.02 pressure loss for the electric heater being in the airstream. There's a 0.04 loss for just a low efficiency filter, the supply grill, the return grill, and a balancing damper. So when I look at the total of the component losses, 0.14. 3, 6, 7, 8, 9, 10, yeah, 0.14 if you add all those up. So you take the 0.14 from the 0.5, I've got 0.36 available. And the total effective length is 463. And if you do the equation, if you divide that by 4.63, because your duckulators are per 100 feet. Friction loss per 100 feet here. Now, if anybody's saying, there's a standard duckulator, this one is a good one because it's got flex duct on the back of it. Most everybody sizes flex duct using the sheet metal calculator, and that's wrong. So this was a nice one. I think I got it from Ralph Easterday. It's got both of them on it. So if
How much would it change your efficiency if you went to a higher medium filter?
We'll do it. Let's say it has a little, like a 2-inch pleated or something like that you put it in. I don't know, let's say it's 0.08 or something. So if I'm looking at this duckulator, I'm going to use a 0.08 factor for sizing my ductwork right there. So if we change that to, I don't know, 0.08, we double that. Now I'm going to use a 0.7 on my duculator. So it made a difference on it. Put a little bit more strain on that motor, and it could upsize the ductwork. So we'll go back to my point, 0.04. So if you were using a ductulator, it'd be a 0.08. So then when you go to your duct sizing chart, based on the rooms we had on our Manual J, and if you put your heating loss and your cooling gain, it's going to figure a CFM for each room. Both of those are going to total 1,050. But if you notice, we're going to have to actually design our duct system for 1,118 because we're taking the maximum of here. See, this is 123. I'm taking 153. I'm putting 153 CFM in that room on the heating side. So you take the maximum of that. And then the ductulator is already built into the spreadsheet, so it'll tell you the round size for your runout. And it'll give your velocity, and if your velocity gets to be too high, it'll bump you to the next size pipe here. And if you were wanting to run rectangular like some wall stack duct, so if I put a 3.5, that's really, what, 3 1/4, isn't it? If I put 3.25 wall stack duct in there, it'll give you the equivalent width if you want to on that. So then if you come down to your trunk line, all you have to do is, this is supply trunk number 1, and it carries every single run on the system, all 11 runs. 1,050 CFM, it calculates a 16-inch round, looks at the velocity, it's okay, so it's 16-inch, and it'll give me an equivalent rectangular duct and then an equivalent flex. Notice that flex is 18 versus sheet metal is 18. If I wanted to change that to a 10-inch rectangular, it'll change those numbers as well. So I can give you your round sheet metal, I can give you your rectangular sheet metal, or I can give you flex duct. You make your choice which one you want to put in. If you can see if I add a run, I didn't mean to do it there. Oh. See, it keeps bumping it. All you have to do is click the boxes. What runs are on that trunk line? If you had a third trunk line, say you had a little branch going off to a room, these two runs were branching off here. Well, that would be an 8-inch run carrying 189 CFM. So it's real easy to do your trunk line, and this is done automatically for you. And your return is the same way. I just got one return duct, so all these supplies come out of return duct 1. So it's a 16-inch round, 25 by 8, or 18-inch flex.
So your computer figured all this stuff out.
Computer does everything.
What are these contractors gonna do now?
I mean, it's really, I mean, that work's done. Getting here, figuring out your fittings every time you've got a connection, at all your fittings to there to get that equivalent length. But it's looking at it in 100-foot increments, so you don't have to be, right on that. But get your equivalent length. Come here. You've already got your book out selecting which piece of equipment. You just get, okay, I need 1,050 CFM. How much static pressure do I have? And then I could raise that to the medium speed, and then maybe change that to 1,100 CFM. Might change the dynamics of it. Or it may have taken high speed to get me to 1,050. So, but yeah, it's pretty simple. So I think Manual J is simple. I think Manual S is pretty simple. I think Manual D is pretty simple. It's just getting it and getting comfortable using it. Then it's just like anything else, man. You can almost do it blindfolded. It's real easy.
Yeah, but it's not as good as 500 square feet per center.
Yeah. Let me show you. I've created the. I don't know if any of you are going to start using iPads or tablet type computers. I've created a version of the Manual J for an iPad. It's even easier than the other one I showed you. It may take this just a minute to come up. So if you had an iPad, and especially if you're out this is only a block load, because I think if you're going out into the field, you're going into somebody's home, you're just looking at a block load to see if the size of the equipment's correctly on that. You're not really going to do a room by room. The ductwork's already in. So this is good to carry out on an existing situation. So all you have to do, the yellow cell is the only one you got to type in. We'll put test there. And then you select your design city. We'll do Huntsville, Alabama. Outdoor design. 1495. Fill out your design conditions. Then from there, if you'll just go to your, here's your glass, so you can select, there's double pane, vinyl clad, operable glass. Then I'll put in the amount per direction. So if I've got 20 on the north, and I've got, let's say, 150 on east and west, and 45 on south. Then doors, let's say I'll put 40 square feet on doors. My walls, net wall area, let's say I got 1450. My ceiling, let's say this is about a 1,500 square foot house. Same thing on crawl space. Floors. My appliance load's already in there. That's the bedrooms I've got. Living area square footage was 1,500. Have no fireplaces, basically. Everything else I've got in there. So I've come up with a 2.6 ton load right here. Less than a minute. I mean, I challenged the guy one time. He said he had the fastest load calculation program. It was one of those trade shows. Yeah, I killed him, hands down. Now, this one has that sensible heat ratio built in it. And I've got 0.78 in there as a default. So now we had 0.81 on that unit, didn't we? So, whoops. So now I can hit that, change that to 0.81. It went from a 2.6 to a 2.5 estimated tonnage. So real quick and easy way to do a load calculation. I've got all these different programs. The green ones up here are sized for a tablet, because you can't run a load calculation, I don't think, on a smartphone. Screen's just not big enough for that. So I got the equipment selection is manual S. The energy analysis is operating costs kind of work together. One of them is if you're comparing a change-out situation. You know, they're trying to decide whether to replace the unit. It's a compressor repair. Are you going to spend $1,200 on a compressor or X amount to put a new unit in? It kind of shows them, you keep that unit 3 more years. If you had the other one, it would save you this much money. It gives a payback. And the other one does it comparing a 13 SEER to an 18 SEER. So you can make estimates. The blue ones all work off of will fit a smartphone screen. And they're pretty neat. Let's just say, for instance, duculator. Hit the duculator. You can hit, we had a 0.08 friction loss rate, so you just hit 0.08 friction loss rate. You go next. My airflow, let's do 1100, and I'm done. Figures everything out. Let's say I run 16-inch metal and 8 or 18-inch flex. Say I drop off, my next reduction is going to be at, let's say, 800 CFM. Now I got 14 round or 16-inch flex or 20 by 8. Also figures there's a friction factor for liner and there's a friction factor for duct board. So it'll figure you got mainly 2 entries to put in, friction loss rate and airflow, and unless you want to change your height on your duct work, you know, from 8 to 9 or 10, you know, it'll change that. But much better than trying to find my slide rule calculator and sit here and try to line them little tick marks up or something. And you know, you design a job, you send it out in the field with installers, and he's got to make a change. Something's in the way or whatever. he can pull his phone off his belt, sit right here, and resize ductwork right on, right on the phone like that. So I've got.
What's the cost for these apps?
I'm in negotiation with ACA right now. I think they're gonna market them for me. So I don't want to throw out in because I don't know what they may go with. But you see, I've got I configure cooling capacity. So here, this is something that probably should be done on every startup or maintenance that you go on. So if you measure the volts and the amps and get your supply and return, I'm moving 1,062 CFM. If I take my two wet bulb temperatures, I got 31,000 total cooling. My dry bulb temperatures, I got 21,789 sensible and 9289 latent. Nice little program to calculate capacity of the units. Like I said, all I'm doing right on the smartphone. I'm gonna go back to the iPad because it's easier to maneuver on that. They'll work on an iPad. They'll work on a desktop. So if you want to use the duculator at your office, you can still use it too. But if I had, let's say, some of them are pretty unique, like this. Like I've got a loan calculator if you're trying to finance a job. But this one came up one day because of all the new equipment is larger, and we're having to pour pads. And so I made a concrete pad calculator. It's pretty slick. Oh, and I got an insulation one too. He left, didn't he? On the concrete pad calculator, if I put in, I need a pad that's say 4 by 6. I'm going to pour it 6 inches thick. And why is that losing that? Losing my signal. Losing my signal. All right, 5% waste factor. So that tells me I need 0.47 cubic yards. If I'm going to go to Lowe's or Home Depot, I got to get 28 60-pound bags or 21 80-pound bags. So you make a choice. Hey, I don't want to do that many bags. So it's going to be a 1 yard minimum on a truck. I'll just have him come out and and pour it. Insulation. If I have an existing insulation of fiberglass loose fill, and I measure it, and I have 4.75 inches. That's an R17.1, and I want to get that thing up to an R38, and I want to use the same fiberglass loose fill. I need 5.8 more inches on top of that to get the required amount. So they're just little bitty calculators that are handy to use. Kind of like I call it the Swiss Army knife. Now you got everything you need on a smartphone. You got a camera, and you got your email and calculators, levels, all kind of stuff like that. So, but I'm trying to wrap all that up, and that should be available through ACA's website sometime in the near future. But there's like I can check superheat with the refrigerant type. It'll give you the suction pressure, saturation temperature. You measure line. I got a 7-degree superheat. Little easy calculator. Wire sizing, gas pipe sizing. That's about all I've got. Any questions, discussion, comments? You guys want to? Tired, ready to go home? Been a long day.